Hello everyone, today we're going to be talking about independent and dependent events and finding the probability of them. So, events are independent if one of the events occurring does not affect the probability of the second event occurring, okay? And most of the time in these problems, we're going to see the word and right here. Whenever we see the word and, that's telling us to multiply things together, okay? So independent events, an example would be if I had a bag of Skittles, if I pull a Skittle out, decide I don't want to eat it, put it back in, the probability of that second event happening is not going to change because I replaced the Skittle in the bag. Or if I have a deck of cards, the probability of getting a 7 would be 1 out of 13. So if I pull a 7 out, but then I put it back in, my probability of getting a 7 is still 1 out of 13. So here's the formula for finding independent events. So if I want to find the probability of event A and B happening at the same time, I'm just going to multiply the probability of A by the probability of B. Okay, you might also see this written like this. Remember, we talked about set notation. Whenever you see this symbol, that just means and. So these are the exact same thing. So here's an example. It says a coin is tossed and a 6-sided die is rolled. Find the probability of landing on the head side of the coin and rolling a 3 on the die. Okay, so we're trying to find probability of head and 3. Okay, so first, the probability of landing on heads. There is one head on the coin, and there are 2 sides, okay? The second one, probability of rolling a 3 on the 6-sided die. There is 1 3 on the coin, or on the die. There are 6 sides, and we're just going to multiply these 2 things together. So we end up with 1 over 12, okay? So that is our answer in fraction form. We could also put it in decimal form. So if I did 1 divided by 12, we're going to end up with 0.0833. Let's put 4 numbers after the decimal point. This would also be 8.33%. Okay, so our answer could be written in any of these 3 ways. Sometimes we're going to be asked for a certain way to write our answer, okay? But that's our answer there. Here's another one. A card is chosen randomly from a deck of 52 cards. It is then replaced and a second card is chosen. What's the probability of choosing a jack and an 8, okay? So there are 4 jacks in a deck of playing cards if you're not familiar with that. So my probability of getting a jack would be 4 out of 52, okay? There's also 4 8s. So again, my probability of getting an 8 would also be 4 out of 52. Okay, so again, we're just gonna multiply these things together. So that gives me 16 over, that's gonna be 52 times 52 is 2,704. So we have it as a fraction. Let's try to simplify this. So if you just put this into your calculator, and simplify, we're going to get this simplifies to 1 out of 169, or 1 over 169, okay? If I put this as a decimal, it would be 0.0059. Or if we wanted a percentage here, this would be 0.59%. Okay, so this is not very likely to happen. So if we look at these odds here, saying that out of 169 tries, we only expect this to happen 1 time. or it's less than 1% of the time that that's going to happen. Okay, here's another example. It says a school survey found that 9 out of 10 students like pizza. If 3 students are chosen at random with replacement, what is the probability that all 3 students like pizza? Okay, so what that means is I'm picking a student, but then I'm putting them back in the group. So I actually could pick that same student again. Okay, so the probability that a student likes pizza is 9 out of 10. Okay, so that goes with that one. This one's also 9 over 10, and then also 9 over 10. So we're just going to multiply all 3 of these things together. Okay, so we end up with 729 over 1,000. And that does not simplify. So it's just going to stay, the fraction form is going to be that. The decimal for that would be 0.729. Or if we wanted a percentage, it's 72.9%. Okay, so it's actually very likely that if I picked 3 students, they all would like pizza. Okay, so another thing we're going to talk about today is dependent events. So dependent events are going to affect the probability of another event happening. Okay, so we're usually going to see the words without replacement on problems like this. Okay, and still means multiply. So we're still going to be multiplying here. There is a formula for dependent events, but most of the time we're not really going to use it. It's actually simpler to think about what's happening in the problem. But these are your formulas for dependent events. All right, next example, a random sample of parts coming off a machine is done by an inspection, has found that 5 out of 100 parts are bad on average. If we were to do a new sample, what's the probability that he picks a bad part and then picks another bad part if he doesn't replace the first? Okay, so if there are 5 bad parts out of 100, that would be 5 over 100. So now for the second one, there's only 4 bad parts remaining out of 99. So that's going to be 20 over 9,900. Okay, we can simplify that, and that's going to be this. 1 over 495. As a decimal, that would be 0.002. As a percentage, we would say 0.2%. So that would not be very likely. Okay, but there's our probability. Okay, sometimes we're going to determine if events are independent or not, and basically we're going to use the formula that we use for independent probability to figure that out. Okay, so if this formula gives me a true statement, if this is equal to this, then these events are independent. If it's not true, then the events are actually dependent. So here's an example. It says let event M equal taking a math class, let event S equal taking a science class, and M and S is taking a math and a science class. So then it says, suppose that probability M is 0.6, S is 0.5, and M and S is 0.3. Are these events independent? So the formula is this: probability of M and S equal to probability of M times probability of S. And we're just going to plug these things in. So 0.3 is equal to 0.6 times 0.5. And if we multiply 0.6 and 0.5 together, we get this. So since this is true, these events are independent. Okay, one more example. It says in a particular college class, 60% of the students are female, 50% of all students in the class have long hair. Of the students are female and have long hair. Of the female students, 75% have long hair. Let F be the event that the student is female, L be the student has long hair. One student is picked randomly. Are the events independent here? Okay, so here we're going to say probability of female and long hair is equal to probability of being female times probability of having long hair. Okay, so we're told that the probability of both of these things happening is 45%. So this would be 0.45 right here. Okay, probability of being female is 60%, so 0.6 times 0.5. Let me say 0 point for all these. So if I multiply that, I get this: 0.45 is equal to 0.3. And this is not true. Okay, so these events are not independent. And that's it. So please go check out the assignment on Canvas and let me know if you have any questions, and have a great day.